Okay, guys, Algebra 1, first period, ninth period. Continuing on our little quadratic journey. We talked about, the basics of a quadratic. We talked about the parent function of a quadratic. Now we're going to start talking about the specifics of, how do we find some of these values? How do we find the axis symmetry? How do we find the vertex if we're not given a graph or if we don't want to graph it? Because graphing's a pain. It takes a while. We should learn ways to figure out this stuff just given an equation, just given a quadratic standard form equation. All right, and the first one up is, and I'm splitting these up because, no one wants to watch a 20-minute video, so I'm making a bunch of shorter ones. First one up is the axis symmetry. It's an important part. There is a formula for it. You are going to have to memorize it for whenever we get back in session. The axis of symmetry formula. Axis of symmetry can be found by doing the opposite of the b value, or negative b, divided by 2 times a. Negative b over 2a. Or I usually say the opposite of b over 2a. So if your b value is negative, make it positive. If it's positive, make it negative. The opposite of b over 2a. Now for the regular class and for both classes, I don't prove that. I don't say why. I do have a video on my channel that has a proof of why it's negative b over 2a. If you want to watch it, search axis symmetry proof. But that's the axis of symmetry. Remember what the axis of symmetry is. It's also the x value of the vertex. So if you have the formula for the axis of symmetry, you also have the formula for the x value of the vertex. Okay. Well, if you have the x value of the vertex, you're halfway to finding the full vertex. Okay. If you have the x value, you just need the y value. And whenever you have an x value and need a y value, you just plug that value in. Okay. So your vertex is going to be the point. Well, the x value is the axis of symmetry. It's the opposite of b over 2a. The y value is going to be whatever happened when you plug that in. Okay. So it's going to be f of whatever the negative b over 2a was. Okay. Remember, that's function notation. That just means we're plugging in negative b over 2a into the equation as the independent variable, as the x value. So let's write that down. So again, to find that, all you're doing is plugging in the x value. Okay. And then just evaluate that expression. And again, the x value is also the axis of symmetry, AOS. Okay. All right, and that's just your vertex is going to be a point. It's going to be a point x, y, or again, sometimes x, f of x, input, output, independent, dependent. Okay. All right, so we're going to be able to find the axis of symmetry now. We're going to be able to find the vertex. What else can we find out about these graphs or about these functions? Okay. Well, we've only seen one type so far, but I've mentioned that parabolas can either open up or open down. Okay. And how do we know if they open up or down, or what determines if they open up or down? Well, that part depends on the a value. Okay. Remember, the a value is part of the ax squared term, the quadratic term. It's going to be the number that's in front of the x squared part of the quadratic. Okay. And the number actually doesn't matter. We don't care if it's what number it is. We care about if it's positive or negative. Okay. So if your a value is greater than 0, meaning it's a positive number. Then that means a lot of things. First of all, it means that your parabola is going to open up. Second thing that means, well, if your parabola opens up, it means your vertex is going to be the minimum. Okay. So the vertex is going to be the lowest point on that graph. And if that's the lowest point on the graph, you could figure out the range. The range of that graph is going to be y is greater than or equal to the y value of the vertex. So whatever the y value of the vertex is, that's going to be the lowest point. It's going to be part of your range. Every y value is going to be bigger than that. Or as an interval, it would be the y value of the vertex to infinity. All right, and then real quick, obviously, if it's negative, try and write this quickly. If it's negative, the opposite's true for all these. Okay, so if a is less than 0, meaning it's negative, then your parabola is going to open down. Your vertex is going to be the maximum. And your range is going to be the flip of what we just wrote. It's going to be your y values are going to be less than or equal to the y value of the max, or the y value of the vertex. Or as an interval, it's going to go from negative infinity up until the y value of the vertex bracket. All right, so A gives you a lot of information. There's one last key graph feature that we have to talk about, and that's the y-intercept. Okay. So these virtual lessons, I don't have to ask any questions. But if we were in class, I would ask, how do we find the y-intercept? What's true about every y-intercept? Okay. And the correct answer to that is that every y-intercept has an x value of 0. So if you have, normally if we want to find the x-intercept, we just plug in 0 for x. Whatever y is automatically the x-intercept. Or the y-intercept. Same thing here. We have a function, a standard form function, f of x equals ax squared plus bx plus c. Whoops. All right, plus c. Now, if we want to find the y-intercept of that, we would plug in 0 for all the x's. So we'd be finding f of 0 equals a times 0 squared plus b times 0 plus c. Now, the multiplicative property of 0, we know all those would go away. So we'd just be left with f of 0 equaling c. Which means that c is always going to be the y-intercept. That constant term is always the y-intercept. So it's always going to be the point 0, c. So before anytime you see a quadratic function in standard form, look at c. Boom, you already know the y-intercept automatically. Okay. All right, so that was the note portion. I'm going to do a separate video for the example problem. And that should be enough for the homework.